Hello all, my name is Jeeten Kapoor, and I will be presenting the topic of smart contracts in 20 minutes. Okay, so let's start with a simple definition. Smart contracts are nothing but simply programs or protocols stored on a blockchain that run when some predetermined condition is met. And because it exists on the blockchain, they inherit various security and privacy properties. They are typically used to automate the execution of an agreement so that all the participants can be certain of an outcome and have trust without the need of a middleman's involvement. Smart contracts are also immutable, meaning it cannot be changed or updated once they are deployed on the blockchain. To change the logic of a contract, one will have to deploy a new version at a new address. For this reason, testing and auditing is very important in smart contracts. All this seems simple enough, but the capability to write programs on top of the blockchain has very far-reaching consequences. Even though Bitcoin is still the largest cryptocurrency, maybe because of the first mover's advantage, Ethereum turned out to be the second largest, mostly because Ethereum was the first cryptocurrency to launch generalized smart contract functionality. As a side note, Bitcoin also supports smart contracts, but it has far more limited use as compared to Ethereum. Things like tokens, dApps, all these are possible because of the smart contracts. Okay, so now let's take a look at an example to understand how smart contracts can help in reducing the need of third parties in order to establish trust. We will look at a popular application of smart contracts, a no middleman Kickstarter. For the sake of completeness, let's take a look at the aim of any traditional Kickstarter platform. Kickstarter platforms are large fundraising platforms where a product team can go, create a project, set up a funding goal, and start creating or collecting money from others who believe in the idea. Traditional Kickstarters are essentially a third party that sits between the product team and their supporters. This means that both of them needs to trust the Kickstarter in order to handle their money correctly. If the projects get funded, the project team expects the Kickstarter to give them the money. On the other hand, supporters want their money to go to the project if it was funded or to get a refund if that wasn't the case. Both the product team and its supporters have to trust the Kickstarter. But with the smart contracts, we can build a similar system that doesn't require a third party. We can program the smart contract to hold all the received funds until a certain goal is reached. We can also see that if that's the case, the supporters of the project can now transfer the money to the smart contract. If the projects get fully funded, the contract automatically passes the money to the project, and if the project fails to meet the goal, the money automatically goes back to the supporters. What is elegant about this is the fact that the smart contract would be stored on the blockchain. Everything is completely distributed. With this technique, no one is in control of the money. But still, the valid question to ask is why we can trust the smart contract? Well, because smart contracts are stored on the blockchain, they are immutable and they are distributed. And also all the security features of the blockchain is also protecting the integrity of the smart contract and its logic. Okay, so now let's look at how smart contracts actually work. Similar to a transfer of value on a blockchain, deployment of smart contracts on a blockchain occurs by sending a transaction from a wallet for the blockchain. The transaction includes the compiled code for the smart contract as well as a special receiver's address. This transaction must then be included in a block that is added to the blockchain, at which point the smart contract's code will execute for the first time and will establish the initial state of the smart contract. Byzantine fault algorithms secure the smart contract in a decentralized way from the attempts to tamper it. Once a smart contract is deployed, it cannot be updated. Smart contracts on a blockchain can store arbitrary state and can execute arbitrary computations. And clients interact with the smart contracts through transactions. Such transactions with a smart contract can also invoke other smart contracts. These transactions might also result in a changing of the state, sending of coins from one smart contract to another or to another account altogether. The most popular blockchain platform for running smart contracts is Ethereum. On Ethereum, smart contracts are typically written in a Turing-complete programming language called Solidity, which is then compiled to a low-level language called bytecode, which can be executed on the Ethereum virtual machine, also called as EVM. Due to the halting problem and other security problems, Turing completeness is considered to be a risk and is deliberately avoided by some language like Viper. There are many other blockchain platforms that support smart contracts, examples of which are Bitcoin, Cardano, EOS.io, and Tezos. Now, let's go deeper into how exactly a smart contract works on the Ethereum platform. But before doing that, we need to understand how does an EVM or Ethereum virtual machine works. The Ethereum virtual machine's physical instantiation can't be described or pinpoint to one location. In the same way, you can't describe where exactly a wave is in the ocean. EVM exists as a single entity maintained by thousands of connected computers running an Ethereum client. The Ethereum protocol itself exists solely for the purpose of keeping the continuous, uninterrupted, and immutable operation of this special state machine. EVM can be thought of as the environment in which all Ethereum accounts and smart contracts live. And at any given block in the chain, Ethereum has one and only one state, and the EVM is what defines the rule for computing the next valid state from one block to another. The analogy of a distributed ledger is often used to describe blockchains like Bitcoin, which enables a decentralized currency using fundamental tools of cryptography. A cryptocurrency behaves like normal currency because the rule which governs what one can do and cannot do to modify the ledger comes from whatever the rules are for the normal currency in the normal world. For example, a Bitcoin address cannot spend more Bitcoin than it has previously received. This rule underpins all the transactions on the Bitcoin and many other blockchain platforms. While Ethereum has its own native cryptocurrency, that is Ether, that follows almost exactly the same intuitive rules. It also enables a much powerful function that is of smart contracts. For this more complex feature, a sophisticated analogy is required. Instead of a distributed ledger, Ethereum can be described as a distributed state machine. Ethereum's state is a large data structure which holds not only the accounts and the balances, but a machine state, which can change from block to block according to a predefined set of rules, and which can execute an arbitrary machine code. The specific rules of changing state from block to block is defined by the EVM. So in a sense, EVM behaves as a mathematical function would. Given an input, it creates the deterministic output. It therefore is quite helpful for more formally describing Ethereum as a state transition function. Given the background we have now of how Ethereum works and what EVM is, we can now talk about what smart contracts are and how they work specifically on Ethereum. A smart contract is simply a program that runs on the Ethereum blockchain. It is a collection of code that are its functions and the data that is its state that resides at a specific address on the Ethereum blockchain. Smart contracts are a type of Ethereum account only. This means they have a balance and they can send transactions over the network. However, they are not controlled by a user. Instead, they are deployed to the network and run as programmed. User accounts can interact with smart contracts by submitting transactions that execute a function defined on the smart contract. Smart contracts can define rules like a regular contract and automatically enforce them via the code. Smart contracts cannot be deleted by default, and interactions with them are irreversible. Anyone can write a smart contract and deploy it on the network. That is, it is permissionless. You just need to learn how to code the smart contract in some language, and you need to have enough Ethereum to deploy the contract. Deploying a contract is technically a transaction, so you need to pay a fees in the form of gas. In the same way, you need to pay gas for a simple Ethereum transaction. Gas costs for the contract deployment are far higher Let's look at an example to better understand the mechanism of gas and how it is calculated for execution of any smart contract. Let's start simple. Let's say Alice wants to pay Bob 1 ETH. Before looking at the formulas, we should have understanding of some of the terms used in it. First is gas limit, which refers to the maximum amount of gas you are willing to consume on a transaction. More complicated transactions involve involving smart contracts require more computational work, so they require higher gas limit than a simple payment. But in a standard ETH transfer case like this, the gas limit of 21,000 units is ought to cover it, as that is the standard gas unit required for ETH transfer case. Now, as explained earlier, every block has a base fee, which is the minimum price per unit gas for inclusion in the block, which is calculated algorithmically by the network based on the demand for block space. The base fee of the transaction is burnt. Users are also expected to set up a tip in their transactions in order to incentivize the miners to add their transactions in the block. Users can also specify an optional maximum limit which they are willing to pay for a transaction to be executed. This optional parameter is known as max fee per gas. For a transaction to be executed, the max fee must exceed the sum of base fee and the tip. Till the point that isn't the case, the transaction is not executed. But when it does, the sender is refunded the difference between the max fee and the actual fee that it took to execute, which is the sum of base fee and the tip. Calculating the transaction fee works as follows. So you multiply the gas limit by the base fee and the tip. This is the total transaction fee. In our case, let's say Alice sets the gas limit as 21,000 units and assuming the current base fee as 100 GUI. A side note, GUI is just a smaller unit of ETH, which translates to 1 GUI is equal to 10 to the power minus 9 ETH. And let's also assume that Alice has included a tip of 10 GUI. Doing the calculations, we find out that Alice would have to spend 0.00231 ETH for this transaction. In this case, because Alice didn't provide any parameter, any value for the parameter max fee per gas, there would be no refund. Although smart contracts are a wonderful thing and has a lot of potential, there are some open challenges. Smart contracts have no straightforward way to cater to the requirement for change in the logic of the code. Also, there are no rights to remedy. And also, because it is openly available on the public blockchain, the codes are visible to all the nodes. Hence, it is also easier to exploit. Thank you for listening. This is all from my side.